This question gives us a differential equation. That means it gives us dy by dx in terms of x and y, and it asks for a solution. So that means it's asking for y equals. So an expression in terms of x. So it wants y equals. These values that they give us, x and y, these are initial values that we will use to find the constant of integration later. So don't worry about this for now. Let's deal with this. So you have dy over dx equals 3 over y cosine squared x. Now the only way to get rid of dy or dx and convert it to y or x is through integration. But to integrate, we need the variable y alongside dy, and we want the dx alongside x. And dx has to be in the numerator. It can't be in the denominator. So what we do is we can multiply both sides by dx. So that will remove that from there. And then we can multiply both sides by y. And that will remove this y from here. So you're then left with y dy equals 3 over cosine squared x dx. Now you've got y alongside the y and the x alongside dx, and dx and dy are both in the numerator, not in the denominator. Now we're ready to integrate. So you can integrate both sides. So the integral of y is easy. It's simply y squared over 2 plus constant, but we don't need to worry about the constant on the left-hand side because we can add it to the constant on the right-hand side. So the integral of y is y squared over 2. What's the integral of cosine squared in the denominator? Well, you probably don't know that, but you do know that whenever there's a cosine in the denominator, you can write that as secant x. So that's the definition of secant x. So we can rewrite our integration as 3 secant squared x dx. So the 3 remains as it is. Imagine there's a 1 here, so 1 over cosine is secant, and because it's squared, it's secant squared. Now we know that the integral of secant squared is tan x, because we know that the derivative of tan x is secant squared. So on the front page of your exam papers, they should tell you this, that the derivative of tan is secant squared. So that means the integral of secant squared is tan. So we can now rewrite this as 3, because that's unchanged, times tan x plus constant. So that's y squared over 2. So that is the end of the solution, except this is called the general solution. Why is it called a general solution? Because we still don't know what the value for c is. So if you plug in the given values of pi over 4 and 2, let's put 2 instead of y, and pi over 4 instead of x. That will give you 2 squared over 2 equals 3 tan pi over 4 plus c. Now, tan pi over 4 is 1, and that's 4 over 2 is 2. So 2 take away 3 is minus 1. That's your value for C. So now we can rewrite this with the value that we just found for C. So this is almost our final particular solution. So they said solve, so we've solved it, except, so that's the value for C. Except we still don't have y equals, so we need to get rid of the 2, so we can multiply both sides by 2 and then take a square root. So y squared is 6 tan x minus 2. So I've multiplied by 2. And then to get rid of the square root, I could just do that. So this is my final solution. So if they ask for the final solution linking y and x, this is it.